Okay, we are going to look at number base, which is the next topic on the board. Now, what is number base? A number base is a system of counting developed over the years by human beings. Yes, human beings have made effort to assert how or to devise a means of counting numbers because there are natural environments even around them that they need arose to be counted. So now, of all the number base, the base 10 system, otherwise known as the base decimal base 10, or decimal base system, or we say denary base in some book. Denary base is the most popular, and it is said that it was developed by the Hindu Arabic, probably because human fingers are 10. So the base 10 number system is a system of counting made up of 10 digits, and the digit goes this way: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It starts from 0 and stops at 9. So there is no any other number that you cannot write by combination of these. By combining this number, you can write any digit, and that is why it is the most widely used number base system. As we have base 10, so do we have base 9. And base 9 starts from 0, 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's called base 9. Now, after base 9, we also have base 8, which is 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth, down to base 2, which is the smallest number base system. Now, we can convert from base 10 to any other base of our choice. Now, of utmost importance is one number base, which is called hexadecimal number base, and that is to base 16. And it's written this way: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Yes. When after 9, instead of writing 10, because you combine 1 and 0, you get 10. No need of repetition. We represent it by alphabet A, B, C, D, E, F. This means base 10, base 11, base 12, base 13, base 14, base 15, and then finally base 16. So, these are the number base we are going to look at. How we can convert it from one to the other, their multiplication, addition, so on and so forth. Of course, we will not do all that. We select the important aspect of it. And finally, the equation involving this number base. Yes. Yes. Now, let's go on. Now, let's look at conversion of number base. Now, for example, we should know that base 2 system is made up of 0 and 1. Yes. On no account, base 2 should 2 occur in base 2 number. No, it's not possible. That is an aberration. It's a taboo. It's a mistake. Serious one. The base 2 system is made up of 0 and 1. Why base 3 is 0, 1, 2? Yes. 3. Base 3. There's on no account should 3 appear in base 3 number system. Now, we are going to look at how we can convert from one base to the other. Now, let's take this question. This one say, convert example 1. Convert 100, 100, 111, 111, base 2 to base 5. Yes. Now, this number is in base 2, or you can write it this way: 100, 111. You write small 2 there. It's the same thing. Either you write TWO or you write small 2 here. It's acceptable. Both of them are correct. So they say we should convert it from base 2 to base 5. There is no big deal about this. All we have to do is to follow the normal procedure. Now let's go on. Solution. We have 100, 111, base 2. Now, the rule is that you start numbering these digits from 0. 0, 1, 2, 3, 4, 5. You can see if you count. 0, 1, 2, 3, 4, 5. Now, for you to convert any number base, from one base to the other than base 10. You first of all convert that number to base 10. When you convert to base 10, you now convert to that required number base. Let's convert this to base 10 first of all by our regular expansion that is well taught in the junior secondary. I hope we discussed it last week, and it is very interesting and very comprehensible, understandable. Now, converting this, we have 1 times 2 raised to the power of this 5 plus 0 times 2 raised to the power of this 4 plus 0 times 2 raised to the power of this 3 plus 1 times 2 raised to the power of this 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. Now, this is equal to 2 raised to the power of 5 is 32 times 1 is 32 plus 0 plus 0. Of course, 0 multiplying any number is 0. Plus 2 raised to the power of 2 is 4 times 1 is 4. Plus 2 raised to the power of 1 is 2 times 1 is 2. Plus 2 raised to the power of 0 is 1 times 1 is 1. So this is equal to 32 plus 4 is what? 36 plus 2, 38, 39. So this is 39 base 10. Now, we now convert this 39 base 10 to base 5 by our regular division. Yes. 5 divide 35, 39, we have 7, 7. Remainder 4. 5 divide 7, we have 1, 1. Remainder 2. And 5 divide 5, we have 0, 0. Remainder 1. When we come on, we have 1, 2, 4, base 5. Hence, 1, 0, 0, 1, 1, 1 base 2 is equal to 1, 2, 4 base 5. So we have converted from base 2 to base 5. Remember that, first of all, we converted to base 10 before we now convert this base 10 number to base 5. That is the rule. Whenever you are converting a number from one base to the other, other than base 10, which is not base 10, I mean, you must first of all convert to base 10. After then, you convert to the required number base. Now, let's take another example. Convert 3, 4, 5, 6. Example 2. Before we move on to another one. Convert 3, 4, 5, 6 base 7 to base 10 to base 9. Base 9, yes. Now, this is in base 7, so we have to first of all convert to base 10 as follows. Solution. We have 3, 4, 5, 6. Now, base 7. Here is 0. Here is 1. Here is 2. Here is 3. Now, we start with our regular expansion. We say 3 times 7 raised to the power 3 plus 4 times 7 raised to the power 2 plus 5 times 7 raised to the power 1 plus 6 times 7 raised to the power 0. So, 49. 7 times 7 is 49. 49 times 3, 49 times 7. 49 times 7. 9 times 7 is what? 63. You write 3, carry 6. 4 times 7 is what? 28. 28 plus 6 is what? 34. 3, 4, 3. Now we have 3 times 3, 4, 3 plus 4 times 49 plus 5 times 7 plus 6 times 1. Okay. Now we say 3, 4, 3. 3, 4, 3 times 3. Times 3. 9, 2, 10. Yes. This is what I'm doing. I'm multiplying 43 by this so as to get the supposed value of here. Now, 3 times 3 we know is 9. 3 times 4 is 12. 12, you write 2, carry 1. 3 times 3 is 9. 9 plus 1 is what? 10. So we have 1, 0, 2, 9 here. Plus 49 times 4. Okay. 4, 9 times 4. 9 times 4 is 36. Right? 6 carry 3. 4 times 4 is 16 plus 3 is 19. We have 196. 196 plus 35. 5 times 7 and 6. We add together. 1029 plus 196 plus 35 plus 6. 15, 20, 26. 9 plus 6 is 16. 16 plus 5 is 9 plus 6 is 15. 15 plus 5 is 20. 20 plus 6 is 26. We write 6 carry 2. 4, 13, 16. We write 6 carry 1, 2, 1. So this is equal to 1266 base 10. Yes, we have converted from base 7 to base 10. 1266 base 10. We now convert 1266 base 10 to the required number base, which is base 9. We draw our line like this. We write 1266. We start dividing by 9. 9 into 12 is 1 remainder 3. Sorry, 9 into 12 is 1 remainder 3. 9 into 36 is 4. And 9 into this is 0. Remainder 6. Yes. Yes. 140 remainder 6. And the 9 we go again. 9 into 14 is 1. And the 9 into 50 is 1. 9 into 14 is 1, remainder 5. 9 into 50 is 5, remainder 5. So we write 5, remainder 5. Yes. Now, we say 9 into 15 is 1, remainder 6. And the 9 into 1 is 0, remainder 1. We use our bottom up technique from down to up. We pick. And this is equal to 1656 base 9. So we have converted to base 9 from base 7. Okay, that's how we can convert number base. Now let's look at a slightly different case. A case where you have decimal points in case of incasity. The purpose of doing this is that you are not in the mind of the examination body. That may be the one you will see in your exam. We don't know. Our own is to do our work. Then you go home and prepare and face your exam. Let's look at the case of decimal point. Case where the decimal points are involved. We are going to solve only one example. With that, you understand. Now, this one say convert. This is example. There is a convert 1022.2021 base 3 to base 5. Solution. Now, there's no big deal about this. We put down our number and indicate the base. 1022.2021 base 3. You have 0, you have 1, you have 2, you have 3, put point. Okay. No. I did not indicate the negative sign. Let me use this marker. Now we have -1, -2, -3, and -4. Yes, that's how it is. You start from minus and progress from -1 to -2, -3 because it's a decimal number. Here now you have 0, 1, 2, 3. So whenever after decimal point, or the first digit there should carry -1. Then progressively, -1, -2, -3, -4 in that order. After the decimal point, when it is a decimal number. But in the case of whole number, you start from 0 and progress to the right, to the left. But in the case of a decimal, you start from after the decimal point and decrease to the right. Of course, you know that in number line, -1 is bigger than -4. -1 means you're only 1. But the minus 4 means you're winning 4. So minus 1 is bigger than minus 4, according to real axis analysis or real analysis. Okay, anyway, let's go on and see how we can do that. We are expanding. Remember, we are expanding in base 3. Now, we now have 1 times 3 raised to the power 3 plus 0 times 3 raised to the power 2 plus 2 times 3 raised to the power 1 plus 2 times 3 raised to the power 0 plus 2 times 3 raised to the power minus 1 plus 0 times 3 raised to the power minus 2 plus 2 times 3 raised to the power minus 3 plus...
So you're covering them. You're covering the board.
Okay.
I don't know how you can write, stretch your hands.
Okay, okay. Plus... Okay, I stopped at 2. Okay, raised to the power minus 3. Okay, plus 1 times 3 raised to the power minus 4. Yes. Okay. Now we have 3 raised to the power 3 is 27 here. 3 raised to the power 2 is 9. Times 0 is 0 plus 0. Now, 3 raised to the power 1 is 3. Times 2 is 6 plus 6. 3 raised to the power 1 is 3 raised to the power 0 is 1. Times 2 is 2. Plus 3 raised to the power minus 1. This is the same thing as saying 2 times 1 over 3. Law of indices, negative power law. Any number raised to the power minus is equal to 1 over the number. So invariably, this will be equal to what? 2 over 3. I hope you understand me. Let me repeat myself. I said that whenever a number is raised to negative power, the answer should be a reciprocal of that number, which is 1 over that number. For example, I say 3 raised to the power minus 1. This will be equal to 1 over 3. Or if I say 3 raised to the power minus 4, this will be equal to 1 all over 3 raised to the power of 4. Of course, you know that here 3 raised to the power 1 is still 3. So that's what I'm doing here now. So we now have 2 over 3 here. Plus 0 here. 3 raised to the power minus 2 is 1 over 9. And 0 is 0. Now plus 2 over 27. I hope this is understood. We have 2 times 3 raised to the power minus 3. This will be equal to 2 times 3, 1 all over 3 raised to the power 3. And is equal to what? 2 times 1 over 27, which is equal to 2 over 27. So we have 2 over 27 here. Plus 1 times 3 raised to the power minus 4, which is equal to 1 all over what? 81. Yes. 1 over 3 raised to the power 4. 3 raised to the power 4 is 81. Now, adding here, we have 27 plus 6 is 30, what? 3. 27 plus 6 is 33. 33 plus 2 is 35. 35. Now, we come to here. This is a fractional problem. We find the LCM. LCM of 3, 27, 81 is what? 81. Now, when 3 divided 81, you have what? You have 27, 27. 27 times 2 is what? 54. Plus, when 3 divide, 27 divided 81, this is 0, is insignificant. 27 divides 0 to 81, you have 3, 3. 3 times 2 is what? 6. You write 6 here. Put plus. 81 divided 81, 1, 1. 1 times 1 is 1. So 51 plus 54 plus 6 is 60. 60 plus 1 is 61. So this is equal to what? 61 all over 81. So what we have now is a 35 phone number 61 over 81. Now we are converting to base 5. Yes, base 5, base 10. We have converted to base 10 now. We will now convert from this base 10 to base 5. Yes. Now, converting to base 5, we have, okay, let's tackle the whole number part aspect of it first. We have 35 divided by 5. We have 7, 7 remainder, 0. 5 here, we have 1, 1 remainder, 2. 5 here, we have 0, 0 remainder, 1. We have 120. from here. Base what? 5. Now we come to here now. We convert 61 to base 5. Now we have 61. 5 here is 2, 2, remainder 1. 5 here is 2, 2, remainder 2. Is 5 here, 0, 0, remainder 2. This is equals 2, 2, 1. Now we come to 81. 5 here is 16, 16, remainder 1. 5 here is 3, 3, remainder 1. 5 here is 0, 0, remainder 3. Now 3, 3, 1, 3, 1, 1. So this is equal to 3, 1, 1 base 5. Now on the whole, combining all, this will give us now 120 equals 120 221 all over 311 all in bracket base 5. That's our final answer. So that's how to evaluate problem of that nature, in case if you come across it in exam. Okay. Now let's look at one example of a hexadecimal before we go to equation in number base. How we can convert a hexadecimal number to number base.